for sticking around for the last talk of the day. I'm excited to tell you about some work that I've been developing with a great team, Keith Burkhart here, to characterize the nutritional quality of restaurants across the country. So, why is this important? Also, don't we know how healthy restaurants are? Well, so in public health research, how this is typically done, how we characterize food environments. You may have heard of terms like food deserts and food swamps. These are based on broad outlet categories. So how many grocery stores are there in a neighborhood, in a census tract? How many fast food outlets are there? We don't look at what these outlets actually contain, what they serve. And so, this begs the question, how many categories do we need? How many categories are important? What is the variability of the nutritional quality of the food within each category? And what is a fast food outlet after all? What is fast casual? What are these different food outlets offering? And this is actually quite important because how this is often operationalized. So how in the literature, fast food outlets, for example, are identified is to use business code listings. Business code listings, for example, the NAICS code. There's a code for limited service restaurants that is taken to be a proxy for fast food outlets. Well, this code, which actually food outlets restaurant chains can bargain with the network to get a certain level. They could be escalated to a full service restaurant. So there are some McDonald's around the country that aren't considered limited service restaurants because of this negotiation that's made. But anyway, the point I'm really trying to make is that the limited service category contains everything from things like McDonald's and a lot of other places and Taco Bell to Sweetgreen and other restaurants that we might think as healthier. So the driving idea behind what we want to do, or what we have done actually, is to take menu data. There's a lot of menu data out there. There's a lot of digital data on restaurants out there. Analyze the menus and try to evaluate the nutritional quality of outlets. But most menus don't actually have nutrients there or don't have information. You get a food item description. So we need to bring in some new methods from machine learning to develop an algorithm to predict the nutritional quality of menu items from the information that I have, which is often just the food item. So that's the first part of our project. And then we also have now that that's done, I'll talk about that. Now that that's done, we can apply this to evaluate the nutritional quality of restaurants across the country because we got our hands on some pretty great data that allows us to do that. So I'm going to talk through, super high level, our prediction problem here. Input, we get things like this, these super high level names like carrot and lentil soup, or kind of weird things like awesome green beans, and we have to make something of that. And then we do some modeling, and then we try to predict this aggregate index of nutritional density. We can also predict the individual nutrients of a menu item, but because we want to come up with a set of metrics that can be used and shared, it's often helpful to have a single metric. So we use this nutrition science validated metric of nutrient density based on how many, the relative proportion of good over bad nutrients. It's a lot more nuanced than that. And then, what that index is, so you can see some of the lowest, the least nutrient dense foods and the most nutrient dense foods there. So we acquired a lot of data to be able to do this. Multiple data sets for training the algorithm. A lot of it has labeled data on nutrients, but then we also acquired this pretty novel data set on the locations and menus for over 600,000 restaurants across the country that we don't have their nutrient levels. So we have to apply the prediction to do that. So we do that in a 3-step model. We have a word embedding model. Basically, we want to be able to leverage information from food data online, from menu data, to be able to think about how food words are considered together in a contextual way. So to be able to incorporate that, we developed this word embedding model, and then we use that word embedding model to predict food item categories. So we categorize all of our foods, we cluster them, and then we try to predict those clusters. And then within those clusters, we predict the nutritional density of any individual food item. So we have a fine-tuned model for each cluster, each food item cluster. And we do a pretty good job at predicting the individual level menu item nutrient density. So R-squared of 0.77. And then when we aggregate up from individual menu items to restaurants, and restaurants to entire neighborhoods, we do a better job at prediction. So to do that aggregation, we define some metrics. Let's just take, for simplicity right now, we take the median across all restaurants, all menu items on for a restaurant's menu to get a score of the nutrition for a restaurant, and then to get a score of nutrition for a neighborhood like a census tract or a city or a larger area, we take the median of all of the restaurants in that area. And this is a result that shows that, lo and behold, when we use these measures to look at the nutrition of all of the different restaurants within, all the different menu items within a restaurant that's labeled as limited service, there's a huge variability. So I'm comparing the variability in limited service restaurants and full service restaurants. There's very wide distribution in limited service restaurants, going up to as high or higher than full service restaurants in terms of healthiness, so to speak. So the value of having something like this. So then we can apply this. So now this is where we start to actually see what we can do with it. So here is our first map of the nutrition of restaurants across the country. We're just showing this aggregated at a county level. We can go down to much smaller geographic areas, but this is over at a county level. And we're showing only counties that have 20 or more restaurants in our data set. And we see these general patterns, like higher nutrition in the West and Northeast, and lower in the South and the Midwest. More blue is more nutritious, more red is less nutritious. And then we can relate this with sociodemographics. So, for example, places that have higher population density, higher percentage Asian Hispanic residents, higher income and higher education, are correlated with much higher nutritional density food environments. And then the areas that have higher SNAP participation, so people on food stamp, and more residents with low-skilled jobs have unhealthier restaurant food environments. And we can also relate this to health outcomes. So we're able to see that there's a very strong relationship between the restaurant nutritional density indicators that we've developed and outcomes like obesity, diabetes, heart disease, and the restaurant food environment is more predictive of all of these health outcomes than whether or not the area is classified as a food desert or a food swamp or something by the outlet level categories. So I think that's all I'll have time for today, but thanks for your time and thanks for being here.